Remote sensing is all about going up as high as you can and drawing what you see. In our age of satellites and AI, I want to tell you about a delightfully human and a delightfully manual way of doing that. The US Forest Service is responsible for conserving some 190 million acres of forests in the United States every year. That's where it all is. To do this, they send a small army of observers into the air aboard planes, arm them with an iPad and a stylus, and tell them to draw all of the dead trees that they see. I'm serious. This is the aerial survey program, and it is the best data set ever, and I want to tell you about it. These surveys don't just tell us where dead trees are, they give us context for why they died. Things like, what was the host species? What was the agents that caused mortality, like fire, disease, or otherwise? And what proportion of all the trees were affected? Here's a very nice polygon. I'm not sure how well you can see the dead trees in there, but they're there. They're a little brown. They were lodgepole pine. They're not lodgepole pine anymore. Now they're just timber. Mountain pine beetle got to them, and it got about 65% of all the trees in there. You might think that this is a very precise and detailed program. It's not. The Forest Service actually has a taxonomy dedicated to the personal style of all the different surveyors and their particular way of marking where dead trees are. Sometimes there's not a lot of dead trees, and instead of making weird blobs, the surveyors will actually mark each individual dead canopy. When that happens, you get a fine snow that looks like this. That's actually normal, by the way. That's kind of what mortality is like supposed to be. Sometimes it looks like this. This is called a lumper. This is someone that looks at a very diverse array of overlapping mortality events and puts them all into nice, neat little boxes. I imagine they don't like it when their food touches on their plate. This is a splitter. This is someone that will happily subdivide and overlap polygons to capture all the little variations of tree death on the landscape. And there's a different lumper up in the corner. You can literally pan around this stuff on a map and see all the different diversity of ways of drawing what's going on here. But the real value is the snapshot of the forest condition we get from these surveys. Every white tick mark you see on here is about 10 standing dead trees. It's a large area, don't freak out too much. But at the same time, this is an imperfect data set. It is profoundly human in a way that is just beautiful to me. Let's look at a different example that isn't as pretty. Come on. Come on. This looks like an octopus. The head of the octopus, that is where you can see a lot of bald spots. But there's that kind of tentacle going left and right. I don't see any dead trees in there. I've spent a lot of time looking at this. I don't see anything in there. Sometimes there's brown, sometimes there's gray, but that's all green to me. To understand why, consider what it's like flying around in a Cessna. You can see, these are real polygons, by the way, of where exactly you might see things over a ridge. But when we consider the true scale of data collected, this was California in 2016, it's pretty hard. In fact, you might ask yourself, wait, Keenan, we have satellites. Why are we sending people into the air? Is this not a waste of my taxpayer dollars? Well, you would be surprised at how bad satellites are at capturing mortality. Look back at the octopus. That's what the satellites find. Just a tiny little fraction of what the true mortality area is within this polygon. So here we really have competing sources of truth, and this is what makes this science such an interesting question to me. This is why satellites aren't very good at capturing mortality. This is what imagery looks like from space. Is that deciduous trees that have brown leaves and are about ready to drop them, or is that mortality? That's an ambiguous question, and it's why products like Global Forest Watch miss a lot. But the real value of the Aerial Detection Survey program is its longevity. We've been doing this since 1927. And it's covered the entire US since the late 90s. So we can ask questions looking through deep time. We can ask, where are the hotspots of mortality? We can start taking these very disparate, very human, very noisy data sets and coalesce them into distinct mortality events. If we integrate over a sufficiently long period, we can track the cumulative area that's been affected. We can make statements about carbon reservoirs, about how climate change is affecting mortality risk, and what we might do to manage this problem. So if dead trees have got you down, consider that every single blob I've shown you here was drawn by a human that cared. And that gives me something to smile about, and so should you. Thanks.